Here we have an Asus laptop that came in for no power. We already disassembled the board, and we're gonna look at the board together and see what's going on. Let's go over to the microscope and start with the DC jack. We have the DC connector here. I'm gonna plug a charging cable, and we wanna see if 19 volts is going in. Cable plugged in. And I'm gonna measure at the MOSFET, as you can see on the screen, on the source and drain. We should have 19 volts. And I'm reading 19.7, and on drain I'm reading 19.7. Gate should be somewhere around 24, and we do have 24.9. If we flip the board, we have a MOSFET on the back also, and we should be reading the same. 19 here, we have 19 here, and the gate 24.9. So we're all good. Voltage is going in. Let's keep going. Just quick visual inspection. I want to see if there's anything burnt or blown or maybe discolored. We have a fuse here, 19.7 volts, and we have 19.7 volts, and we have a lot of MOSFETs here. Okay, what I'm going to do is disconnect power. We're going to manually start measuring components on the board. For example, we have MOSFETs here. Quickly go over gate, source, drain, nothing obvious here. Diode mode reading 0.45, 0.6, 0.48, and 0.8. Let's continue. No reading, that's good. We have 0.336 here. We do not have a short anywhere on the board so far. Okay, so everything is testing very good. Let's go to the V-core circuit. And if we measure in resistance mode, we should have something in the K reading. Sometimes we read 10K, sometimes 30K. It depends on the laptop. Why don't we switch over here so you can see what's going on. Let's measure MOSFET number 1, 29K, that's perfect. MOSFET number 2, 29K, that's perfect. We do not want to be reading a very low value in the ohms or possibly a short. 29K, 29K, 29, 9.7K, that's good. Some of them will read 29, some of them will read 9. As long as we are in the K, we should be good. Like I said, every laptop is different. $9.5K, and we have 9.7K. What if we measure rest of the MOSFETs, the one for the GPU? And they are located right over here. We are reading 27K, and we are reading 27K, and we have two more. We're reading 27K, and we are reading 27K. Let me switch over to the microscope so you can see better. Some people complain, I'm not seeing the reading on your multimeter. You do not have to. Just trust what I'm telling you, and you should be good. I'm not gonna lie to you. But I just did it that way so you can see it. So you know that I'm not getting those numbers out of my... Let's continue with the board. Let's measure here in diode mode. And what do we have? 0.5 voltage drop, 0.7. And if we do between source and gate, we have 0.5 and we have 0.14. 0.14. I forgot if 0.14 is normal or not, but we're gonna find out. So far, I'm not finding anything wrong with the board. We do not have a short circuit anywhere on the board. All MOSFETs are measuring good. If we flip the board, we have our RAM chips on the back. We have a MOSFET here along with the current sense. We already measured this. We have 19 volts going in and out of the MOSFET. Let's go down here. Just quick visual inspection. I may be going too fast for some, but just bear with me. It's like my wife tells me that I walk too fast. I tell her if I walk any slower, I will trip and fall down. So same thing here. If I go any slower, I will not focus. Nothing. We're gonna plug the cable in and monitor the board under a thermal camera and see if we see anything obvious. I have the cable plugged in. Oh, right off the bat I see something here. Let me grab my plastic spudger. We never want to touch anything on the board with a screwdriver or a metal object. Right here. It looks like we're pointing at 3 capacitors here. But I have a feeling heat is not coming from front of the board. Heat is diffused. And look on the back. Yeah, heat is coming from back of the board and not from front of the board. The heat spot is sharp. So obvious. What's this? And just give me 1 second. My daughter came here. And let me just speak to her quick. What's that? For me?
Yeah.
Really?
Macchiato.
Wow. Macchiato. All right. Is that because I dropped my cup in the morning? I knew it. Because this morning, let me just turn the camera like that so they can see that beautiful face. This morning, I made a cup of iced tea. And I came to kiss my daughter and the cup fell down. And I did not have time to make another one. So now she came with this. How nice is that? Okay, and that's the 12855A. Heat is coming from this chip. Now, if we measure around the chip just quickly, meter in diode mode. We do not have a short. 0.4 voltage drop. So we do not have a short on any one of the caps. All 0 ohm resistors are good. The problem is most likely the chip itself. Where are we going to get that chip from? Very good question. I have a lot of donor boards here. And we're going to check and see if we can grab that chip off any one of those donor boards. That's a different board, but even if it's a different board, we can still look for that chip. Most Asus laptops, they use that chip. Let me look for a similar one if possible. That's a different board. And that's a different board. And that's exactly the same board. Exactly the same board. Let's go under the microscope. So I have this one here, right there. See? Right there. I do not know if the chip on this board is good or not. This is a donor board. But let's hope for the best, because I do not have that chip in stock. We're going to remove the chip, we're going to prep the pads, and we're going to hope that the donor chip is good. Maybe the problem is not the chip, but something else affecting the chip. We do not know, but right now, the smart thing to do is to replace the chip, since we have a lot of heat coming off the chip. And of course, pin number 1 is on the top right. You see that line on the top right. Apply some flux, some leaded solder. Let's grab the donor chip. And right now I'm being as gentle as I can. I do not want to over squeeze it, so we don't send it to the 9th dimension. Because when it's the only chip that you have, it's very easy for this to fly away. So we should be all good. Clean up. Alright, so the soldering is perfect. Very nice. We have 1, 2, 3, 4, 5 pins on the top, soldered on nicely and aligned perfectly. Same here. Same here. And the same goes here. Let me just apply some alcohol onto this area so we can cool the board down, because we're going to inspect it under a thermal camera and I want to be able to know if we have heat on that chip or not. Right now the chip is still hot because we applied hot air. So naturally we're going to see heat on that chip if we inspect it under the thermal camera now. That's where we replace the chip, right over here. And I'm going to plug the charging cable. And we're gonna monitor this area. And we still have heat on this area. Great. 249 degrees, 260 degrees Fahrenheit. 300. Okay, so we have to figure this out. So is it possible that the problem is coming from the back or front of the board? Let's flip the board and look at the same location with the board flipped. And that's those caps here. And no, we do not have an issue here. .87. What? Beep, and then 0.87 voltage drop. Let me go to resistance mode. Okay, so I'm reading 55K. Is 55K normal? Let me measure that MOSFET on the donor board. We're going to measure between source and gate. You see, on the donor board, we are reading in the mega ohms, 8 mega ohms between gate and source. So it's a big difference between 8 mega ohms and 55 kilo ohms. And if we measure here, we have OL. We may have a problem here. What happens now if we measure between source and gate? We have 119K, no change. Let's remove the other MOSFET. I just want to eliminate the fact that it could be a MOSFET issue. And if we measure now, no change. No change. Let's check out the data sheet for the 1285A chip. It's a step down controller. And if we go all the way down, usually I want to see the pin layout right here. We see that we have two enable pins, enable 1 and enable 2. VN is pin number 12. We have a feedback line. We have a P-good output here. Driver, switch, a clock. Okay, so I'm interested in seeing if we are getting enable on pin number 20 and pin number 6, and also if we have VN. We should have VN because the chip is getting hot, so VN should be there, but we're gonna check. And we're also gonna check for enable 1 and enable 2. If you go down here, it explains what each pin does. I'm gonna plug the charging cable. The problem is the temperature is reaching about 300 Fahrenheit on that chip, so we cannot keep it for long. And now I'm gonna go to voltage mode and start measuring. Enable 2 is on the bottom right here. And right now I'm reading 0.2. So enable voltage is almost 0. It should be about 3 volts. If we measure enable 1 on top, are we gonna get the same 0.2? And yes, 0.21. And if we measure VN, which should be right here, or this pin here, we should, oh, what happened? The chip blew up. Whoa. I'm gonna have to put this board on hold until I get another chip, because the next thing I was about to say is we do not know if that chip is good or not. So I do not want to base all my measurements on a chip that we do not know is good or bad. What I want to do before we end the video is I want to desolder the chip and I want to check on enable pin 1 and 2. I'm just curious to know if we have enable signal for 1 and 2. If not, then replacing the chip will most likely not fix the problem, and we will have to figure out what makes the enable signal. I do not have any circuit diagrams or board view diagrams for this board, but maybe if you have it, you can send it to me by email, or I'm thinking of creating a section on the forum for schematics, and you can upload stuff there. Let's remove the chip. This is 19 volts, and I think the one next to it is 5 volts. And I've seen this chip burn on many Asus laptops. This is not the first Asus laptop with this problem. Now we cannot remove the chip. The chip molded itself to those traces, 19 volts and I believe 5 volts right next to it. But I managed to get the chip out without ripping those pads. What a mess. What a mess. Look at this. Let's see, what do we have here? Yeah, look at this mess. Look at this mess. Great. Right now what we need to do, restoring those traces is not a big deal. We're gonna run a pad from here to here, and we're gonna run one from here to here. But right now I want to test and see if we have enable on EN1 and EN2. Okay, so I'm gonna plug the power. 1, 2, and 3. Power is plugged in. And let's measure again. Before we got 0.2 on enable 1 and enable 2. If we do not have enable signals, then the chip is not going to function. It's like having a light switch, but the switch is off, so the light bulb is not going to turn on. Let's measure here. We should have 19 volts. Okay, so now I'm not even reading 19 volts. We're going to have to check the MOSFETs and see if those MOSFETs are still good. And we're going to have to check those 0 ohm resistors. And no life. Okay, so we're not even getting 19 volts unless I'm measuring the wrong pin. What about here? No readings, 0 volts, 0 volts. Enable, I think this is enable 2. And enable 1. So right now we are totally gone. 0 on everything. Let me measure the charging adapter. Do we have 19 volts here? And we do. Let's measure the power MOSFET on back of the board. We do not have we do not have voltage here anymore. What about here? Nothing. 0.2 on gate. So we have no voltage on the power MOSFET. Let's check the first power MOSFET, which is this one here right next to the connector, and see if we have anything here. We should have 24 volts, and now we are getting 0.3 volts. No 19 here, and we have 19 here. So we have 19 volts here, but it's not going in because we now probably have a short on the MOSFET on back of the board right next to the current sense resistor. We most likely have a short here now, which is very common on Asus laptops. I've done a lot of videos on this very same problem, but today's problem is unique because that chip just blew out in our face. You want to fix me? Take this. And that's what happened. You see, we have a short now. We have a short right here now. And what is causing the short? Let's inject voltage. I mean, I'm doing all this and I'm not going to be able to fix this laptop today because we do not have the chip, but I'm just curious to know what has shorted. We have a short circuit on the board now. I did not want to leave you hanging, so I just wanted to go further. I wanted to see if we had enable signal, but we do not even have a 19 volt signal. And that happened after the chip burned. It just suddenly decided to burn. Okay, so let's inject voltage right there, right there. Okay, so this is what got hot. This right there. Is it possible that we have a problem with our PCH, which is right here? Very possible. Let me measure in diode mode. Do we have a short here? We have, and we have a short. Let's go to ohms mode. Yeah, we have a short. Let's remove this cap and measure again. Do we still have a short? Meter in diode mode. And we do. Because the coil is getting hot and the coil is connecting with the capacitor. The capacitor is reading that short. Is that normal? Let me check the donor board. See, it should not read a short. It's reading 0.418 voltage drop. So we know that we have a problem there. That's where a board view would come in handy. I measured this MOSFET before and it was good. And I do not see a short on the gate. And gate to source, no short. So we're gonna assume this MOSFET is good. I think I'm gonna leave this repair until another time. In the meantime, I'm gonna order the chip. And we'll see if we can figure it out in part 2. If there is going to be a part 2. That's it. I hope you enjoyed this video. This part 1 of the video, even though it's a no fix. I think I'm gonna create a section for schematics on our forum. So if you do have a schematics and board view diagram for this laptop, you can leave it there. Let me know what you think, and I'll see you again in the next video.